Hi, in this video, we'll see what are the differences between system resource and system resource extend blocks. It is best to use the system resource or system resource extend, that is schedulers, if there are multiple flows in a model or when the request to the resource has to come from many physically separated parts of the model. These blocks split the operation between behavior flow and the platform. The behavior flow describes the application or task of the algorithms, and the platform describes the architecture, which includes the hardware, software, and network. The behavior flow has a block called the mapper, which simply takes the incoming request and sends to the named scheduler. So the schedulers form the architecture part of the behavior and architecture separation methodology. The system resource and system resource extend performs the arbitration like the first come first serve, round robin, and also queuing, pre-computed latency, and the variable latency. And any number of mappers can be targeted to the single scheduler. In both system resource and system resource extend, when the transaction arrives at the head of the queue, it is delayed by the task time value, and after this delay, the data structure is sent to the output. At this point in system resource, the transaction releases the scheduler and returns back to the mapper immediately. But in system resource extend, the external processing is possible before sending the data structure back to the mapper. So any logic can be performed outside of this block, including delays, routing, and can even trigger other operations. At this time, the system resource extend is blocked and no new transaction is processed. When the system resource done block is encountered in the flow from the output port, the transaction releases the scheduler and returns back to the mapper. So the transaction can also continue through the system resource done block. So in this model, we have two resources, and this maps the task to the system resource and this to the extend block. And each task is having the task time as 3 seconds. So now here you can see in system resource block, the task begins at 0 second and executes for 3 seconds. And then it is returned back to the mapper block immediately and displayed at the text display at 3 seconds. Here in system resource extend, even though the task time is 3 seconds, the task got completed at 4 seconds. And it returned back to the mapper at 4 seconds and displayed in the text display. So it is because after the 3-second execution in system resource, it passes through the external processing. Here in the delay block, we have an additional delay of 1 second. So after the processing in the delay block, it reaches the system resource done block and then it returns back to the mapper. So this external processing is used where the server requires data from a cache before completing the processing, or the data needs to be cleared by an interrupt before allowing the next transaction, or to emulate a pipeline stall for a period of time. This system resource extend is the highest level processing resource, such as a bus, CPU, or memory. So this block is preferred where the processing cannot be entirely defined within the block parameter and time value. For example, a processor may need to access memory before completing the processing, like that. So we can model the system components with system resource and system resource extent, like the hardware components, software scheduler or real-time operating system, and even physical entities such as people and conveyor belt, etc. So these are the key differences between system resource and system resource extent blocks. Here, the system resource has the preemption and hierarchical features which are not possible with system resource extend, and system resource extend has the extended task processing, that is external task processing, and the non-blocking features. We'll see one by one in the next slides. The first difference is preemption. So the system resource is used when preemption is required. In FCFS with preemption, the execution operates similar to the first come first serve mode. So when a higher priority transaction arrives and the currently executing task has a lower priority, then the processing task is placed in a preempt queue. The higher priority task starts executing, and when it completes, the task with the next priority starts processing. So the preempted task only processes the time remaining on resumption. In this model, we have three tasks that targets to the system resource. So each task has a priority value as 1, 2, and 3. So the task 3 is having the higher priority value. Higher the number is the highest priority. And each task is having the execution time as 3 seconds. And the scheduler type is set to FCFS with preemption. So now you can see that task 1 starts at 0 second and it is being processed till 2 seconds. At 2 seconds, the task 2 comes to the scheduler. Since it is having the highest priority, the task 1 is being preempted. So the task 2 is being executed. At 4 seconds, the task 3 is coming, which is having the highest priority. So the task 3 is being executed for 3 seconds. After it finishes, the task 2 with the highest priority is being executed. So it is being executed only for the remaining time. Already it executed for 2 seconds and it is now being executed for the remaining 1 second. After that, the lowest priority task 1 is getting executed. So from this plot, you can see how the lower priority task gets preempted and completes after all the higher priority tasks have completed. The next difference is the hierarchical feature. The system resource can operate in the hierarchical mode. In this mode, the incoming data structure or request is sent to another system resource or system resource extent for processing. The current scheduler queues the transaction and when it arrives at the head of the queue, it is sent to the top level scheduler.
This conference will now be recorded.
The next difference is the hierarchical feature. The system resource can operate in the hierarchical mode. In this mode, the incoming data structure or request is sent to another system resource or system resource extent for processing. The current scheduler queues the transactions and when it arrives at the head of the queue, it sends over to the top level scheduler. On return from the scheduler, the transaction is sent back to the original queue. So this model shows how a lower level scheduler sends requests to the higher level scheduler. Here we have three tasks that maps to the lower level scheduler. The scheduler references to the higher level scheduler by using the name of the higher level scheduler in the next resource parameter. So the task will be executed in the higher level scheduler. After completion of this task, the transaction will be sent back to the lower level scheduler and from there to the flow. So from here, you can see the execution of task in the top level scheduler. And here you can see the flow of data. The task first goes into the lower level scheduler. From there, it gets into the top level scheduler. After the execution, it comes out of the top level scheduler and goes to the software block, I mean the lower level scheduler. And from there, it goes back to the mapper block. The next difference is the non-blocking feature in System Resource Extend. Normally with FCFS in System Resource and System Resource Extend, the tasks have to wait for the previous one to finish execution and release the scheduler. That is, it will be blocked. But in non-blocking FCFS, the next transaction does not have to wait for the previous one to reach the done block. That is, multiple tasks can be executed at the same time. This model shows the difference between the first come first serve and non-blocking first come first serve. Here we have concurrent tasks that need to be executed on their resources with the same execution time and enters the resource at the same time. To use the non-blocking mode, select Scheduler Non-Blocking FCFS in the System Resource Extend. So now, here you can see the task 1 starts its execution at 0 second and completes at 4th second. Till that, the task 2 has to wait and then it starts its execution even though they enter the scheduler at the same time. In the non-blocking mode, both the task enters the scheduler at the same time and starts the execution parallelly and completes at the same time. And this feature is not possible with this system resource block. Thank you.